Testing. Testing 1, 2. Okay. What's going on? Oh, that's why. Hey, can you guys hear me? Okay, awesome. Thank you. Hey, Rhea, did you see my email?
Yes.
Okay, was it helpful?
So you just got the equation, like, yourself.
What do you set the equation to?
You just find it.
You gotta find the equation. Yeah, we'll talk. I came up with an example today to go over that. Hopefully will be answer your question too. And we can talk more after class if you want. Okay. All right, sweet. Let's get started. Okay, first thing I want to say is thanks for everybody who's here and tuning in. I know it's like a hard week to want to do anything because there's only 2 days of class, right? So just reminders, problem set 7 and writing assignment 3 are posted, available to do. After today, you should be able to do all of it, like in the sense that this is all the material that I think is going to be on it. Also, there's no class or recitation on Thursday, obviously no class on Wednesday either. Because there's no classes at all on Wednesday, right? Yeah, okay. Cool. So today we're going to go over chapter 9, which is oligopoly, monopolistic competition in the book. We're also going to do a little bit of review of Monopoly. Next Monday, we're going to do macro review, kind of like what we did last week on Wednesday. And then we'll go over more of this stuff. There's one recitation that we weren't able to get to, or that I don't think we'll be able to get to this semester or this like time around because just how things got set up. So we'll go over like an example problem from the recitation that we're not going to be able to go over on Monday. I also think next week might be your guys' last recitation week. Yeah, so if you liked Ishan, tell him thanks. If you didn't like him, tell him I hate you, whatever. No, but I mean, this is his first time doing it, and I feel like I've gotten a lot of good feedback from students and encouraged by how he's doing. I think he's done a much better job in his first time doing this than I have. So, okay. Before we get started on chapter 9, I also want to go over the schedule, a few more things. So we're going to have a review session on the 3rd. I'm still confirming where and when. I'm also going to extend my office hours. I've done a little bit of like reflecting and trying to figure out like, okay, what has gone well for me this semester, what has not gone well. Clearly, like I make mistakes in class, and I can tell because some of you guys get like super pissed at me and have like checked out for the semester. But I want to say for those of you who haven't, like I'm going to try to open up more time to be available over the study period, just so that you guys can come in and ask more questions. And I know that like some of you guys I also know don't like doing that because it can be a little bit tougher, but I'm trying and I'm here. And like, I'm totally aware that you guys are gonna like flame me on Reddit or Corsical or rate my professor or whatever it is. And that's fine, but I'm gonna like keep trying, keep working, and hopefully like for those of you who feel like you need some help, you'll be able to get it either from me or Ishan. Or if you don't like either me or Ishan, I can try and help you find some other resources. If you want to come to class and you're like, or come to office hours and be like, hey, Jacob, I actually hate you and I hate how this is going, which I know some of you are definitely feeling on the inside. I found this resource. Can you tell me if it would be helpful or practical or applicable for the class? I can definitely do that and willing to help however I can, okay? So yeah, that's all that I have to say about that. These are the office hours if you want to write them down. Also, I'm going to post this after class. Yeah. Oh my gosh. Like classic like that. Thanks for bringing that up. Yeah, so you can write this down if you want. I also thought the YouTube video idea was a good idea. And then I got like copyrighted, like they killed my video, like my last video, because I had a clip of the office up on it. So I put it back on Sakai, but over this upcoming weekend, I'm going to work on uploading all of the videos to YouTube, all of the non ones that will get copyrighted, because I realize I use several like videos or whatever. Which actually I looked into it and there's no issues, I don't think, in showing it in class as long as it's for academic use. And I could like apply to overwrite the copyright issue, but it takes forever. I like looked into it, so it's not going to happen this semester. Yeah, so you can write these down if you want. And again, I'll put this up like in the slides so you can review it or whatever. One big thing is I'm doing office hours just this week, just today, because there's no class on Wednesday. So I don't expect anybody to show up. I will be here if you want to come talk to me. I'm here like every day. So you can shoot me an email. But next week, I'm going to have office hours every day from 11 to 12 and 2 to 3. Okay. But it's like by appointment in the sense that email me if you are going to show up. Because like, for example, last week is on Wednesday or Thursday, it was just me and John, and he didn't have any questions for me, which is totally fine. He was just there working and I just sat there the whole time. I would rather sit up in my office and work on my own stuff. And if you have questions for me, I'll come down because my office is just upstairs. So just shoot me an email if you're going to come in. And even if you're just like, oh, I'm working on this stuff and I might have a question, shoot me an email and I will definitely come down. But I'm going to be available for sure at all of these times, 11 to 12 and 2 to 3 every single day, Monday through Friday. And then additionally, I'm going to be available on Saturday the 4th from 1 to 3 and Sunday the 5th from 1 to 3. And we're going to do a review session. And then on Monday, I'm going to be, I didn't put this down because I ran out of space. On Monday, I'm going to be available from all day, meaning from when I'm here until when I leave. I will be available for you guys. I think I have an interview that might be like 30 minutes or an hour somewhere in there on Monday, but otherwise I will be available. Again, just shoot me an email if you're going to come, because I'm not going to go sit down in that office the whole, like in the Econ Aid Center the whole time. Unless there are people there the whole time, I will absolutely go down and do that. Ishan's going to have some office hours, but he didn't know when yet because he's got a couple things he's got to work out. Other things, ULAs are going to have extended office hours. I recommend specifically going to Alex's ULAs. I recommend him specifically because he was in my class previously, and like, so he will know kind of like how I do things. He's technically, I think, a ULA for Professor Staub's 101, but I told him straight up that you guys are going to come see him, and he said that's fine because I don't think anybody goes to see him from Professor Staub's class. And he also is like kind of employed by the Econ Aid Center, so he's able to talk. He's supposed to be able to talk to anybody. So Alex, that's another guy. I don't know when his extended like ULA office hours are going to be, but there's a way to look up the schedule on the econ website. And if you can't figure that out, let me know and I will try to figure out what his are going to be. All the other ULAs would be good too, but just like it's more and more degrees of separation, right? So I know specifically that he will be able to help you guys with exactly how we do things in class. Yeah, I mean, all of them will be able to, it just might take a little bit more time. So any questions about this? Okay, yeah, like I said, I'm aware of my deficiencies, so I'm trying to be able to make up for them a little bit. I hope that people who want to come in and ask questions are able to come in and ask the questions that they want. Okay, okay, cool. So let's get started. We're going to do some review on Monopoly. Okay, I'm going to pause this video. So much, killer. Yeah, so that's not a reason for Monopoly though. Yeah, and then there were a couple other ones, right? What we didn't go over, what we didn't talk about is this idea of kind of like regional monopolies that can prop up and exist. And it's like a mixture of all these different reasons. I mean, you could argue that this tent guy has increasing returns to scale. And so by combining all of these different businesses, he's able to grow his business. But this is also going to have like flavors of an oligopoly too, right? We have multiple different company names and they're all kind of colluding together to act as a monopoly. So we're going to talk about this and how these things kind of overlap. But this is also something that exists in the real world. If you go to different types of franchises, there are people who are constantly trying to what's called horizontally integrate. We're not going to go over this term that much in class, but it's a business concept where if you buy up businesses that are all competing with each other, over time, you can charge a higher price and have the same demand because there's no longer as much competition. Okay, so let's talk about this question here first. Which of the following best describes the market structure for tents in Pawnee, Indiana? So we have perfect competition, monopolistic competition, oligopoly, monopoly, and there is no market for tents. Okay, well, perfect competition, we already have talked about it a little bit, and I want to make this really clear because there are several defining features of perfect competition, and all of them in accordance with one another are kind of how you can identify it, right? Perfect competition, you have to have easy entry, right? It has to be easy to enter. A barrier to entry would be something like, I can't go out and make Tesla cars for a few reasons. I can't make Tesla cars, one, because I don't know how. Okay, so technology. Two, because there's probably going to be some kind of permits that exist, things that exist that make it impossible for me to do it, even if I watch a YouTube video on how to make a Tesla car. And that's like maybe government regulation. There are going to be different reasons. Those would be barriers to entry that would disqualify perfect competition. They also have an identical product or good. So we talked about how that's going to be, in a lot of cases, hard to think about. So usually we're going to think about things like corn or soybeans. A lot of crops are like the only real life examples that I can think of where corn that's used for corn syrup in Minnesota is the same that corn that's used for corn syrup in Pennsylvania is. They're the exact same by design because you need to use the exact same like compounds to make corn syrup eventually. Okay, so I'm gonna rule that one out because tents don't seem like they're necessarily something that they all have to be the same. I've seen different size tents, different color tents, tents that have different features, like some are heated, some are not. Then we have the next three that are going to be, it's going to be a little bit harder to distinguish from. We have monopolistic competition, oligopoly, and monopoly. Okay, well, we talked about briefly at the beginning the different market structures. Monopolistic competition is there has to be some product differentiation, but they're similar products. And then there has to be many owners, okay? And there has to be easy entry or no barriers to enter. Okay, so Seems like there aren't that many barriers to entry, so that would be good. Seems like we could have some product differentiation, but we definitely don't have many owners in this case, right? Because this market is defined by a specific region, Pawnee, Indiana, which is the region that they're talking about. So it's not going to be monopolistically competitive because we only have this one owner, apparently. Okay. Next one, oligopoly. Oligopoly has barriers to entry. And the other big thing about it is that there are few owners. Okay. So again, not going to be oligopoly because there are few owners. We only have one. That only leaves a monopoly, which has barriers to entry, and there's only one owner. Okay, so that's how, if I were given a question like this on a test and I had to think about going through the different things, that's how I would go about doing it. Okay. And just remember, when we're thinking about this, we want to remember all of the different structure, like all of the components of a market structure, so that when we get a question, we can like eliminate each thing based on all the components taken together. Okay. So next thing we're going to go over this question together. You can work on it with the people sitting next to you. I'm going to give you guys like 5-ish minutes to do it. And this is review in the sense that we've gone over Monopoly, but it's not necessarily a review in the sense that we haven't really done a question like this. And so I want to take some time to go over doing a question like this. Okay. So suppose the marginal cost is equal to 10 plus Q for the monopolist, and demand is given by, this is market demand, okay, is given by P equals 100 minus 0.5 QD, okay? Graph the marginal cost, demand, and marginal revenue curves, and then solve for the monopolist quantity and price, and solve for their profits, okay? So the first thing that you're gonna have to do is figure out how to get the marginal revenue curve, and then what their quantity and price will be, and then you can get the profit, okay? And let's say for this last parts, use ATC equals, I'll figure out what the number should be, okay? But the average total cost curve, you're gonna need that too, and I'll figure out what number it should be. ATC equals 60. It's a constant average total cost of 60. Okay. That's a simplification. Okay. I don't know how realistic that is, but I'm just gonna tell you guys that the average total cost is 60. Okay. Okay, I'll give you a hint. If you're struggling a bit, the marginal revenue curve is 100 minus Q. All right. Okay. Who wants a couple more minutes? Okay, we'll do 2 more minutes. All right, let's do 1 more minute and then we'll come back together. Okay, cool. So let's figure out how to get the quantity, the price, and the profits, okay? So I gave you a hint that to get these things, you need to know the marginal revenue and figure out what the marginal revenue curve is. And then I gave you a second hint that the marginal revenue curve is equal to 100 minus Q. Whenever we have a linear demand curve, the slope of the marginal revenue curve is always going to be twice the slope of the demand curve, okay? You can forget the first part of what I said because we always use a linear demand curve, and just remember that the slope of the marginal revenue curve is twice the slope of the demand curve. Okay, so if you're ever not given the marginal revenue curve, but you are given the demand curve, you can get the marginal revenue curve. Okay, it's like a one-to-one mapping. You have the one, you can get the other. Okay, so I know on Achieve, for those of you who work through those problems, definitely there are going to be several problems where they're not going to give you the marginal revenue curve. I think that's good because there's going to be, that's definitely going to be the case on the test where you'll be given just a demand and a supply or demand and a marginal cost curve, and then it's assumed that you know how to get the marginal revenue curve from the demand curve. Okay, so definitely file that one away in the back of your head, and your book also goes over that, like explicitly talks about linear demand curve. The slope of the marginal revenue curve is twice the slope of the demand curve. Okay. Okay, so we have, don't forget to put our axes in, right? This is 10. Then to get the quantity, right, all I have to do is set, oh, well, we don't have a supply curve, but we have the marginal cost curve, which is kind of like the supply curve, and we set that equal to the demand, and then we solve for Q. That gives us the equilibrium quantity. The monopoly is going to choose the equilibrium quantity, right? No, right? No, that's not how we're doing it here. Okay, so we're breaking away from the market here when we have a monopoly. The way to find the monopoly's profit or the monopoly's quantity is to remember that they are profit maximizers, which means they choose Q where MR equals MC. Okay, so the quantity is going to be given, the profit maximizing quantity is going to be the one where marginal revenue equals marginal cost. So we set marginal revenue equal to marginal cost, and we get 100 minus Q equals 10 plus Q. Oops, sorry guys. Okay, and then we get QM or 2QM equals 90 when we get put like terms on the same side, and then we get QM equals 45. Okay, so QM right here equals 45. All good so far? Okay. Next thing that we need to figure out is what their price is going to be. Well, similar to when we had a quota rent for a market in unit 1, they can choose any price up to the demand curve because a monopolist is the only provider in that market. So they don't have to worry about other people coming in and undercutting them or anything like that. So they can choose the highest price that people would be willing to sell at that quantity, which is the quantity up to the demand curve. Okay, so that's this price right here, PM. What does that mean? If they charged a price up here, well, they'd have to have a lower quantity, right? The quantity would be somewhere down here. But that's a problem because that's not going to be the profit maximizing quantity. Okay, I suggest if you're confused by that, you go through and you do on your own what the quantity will be, what the profit will be. You might need a better average total cost curve to get that because I just came up with this one and it's not exactly right, but that's the idea. Okay, so the next thing we have here is to get the price. We need to what? We need to plug our quantity into the demand curve, right? That's just this point right here. It's just QM, PM. Well, we know QM whenever we know one of the two things in a point that is on a line, we can just plug it into the line to get the other coordinate, right? So we say, okay, P equals 100, or PM equals 100 minus 0.5 QM. PM, when we plug in 45 equals 77.5. Okay, so we got the price, we got the quantity. Next thing we need to do is we need to figure out what the average total cost is going to be. And I just kind of pulled one out of the thin air, and I told you guys, let's say that it's going to be, the average total cost is going to be 60. Okay, and if the average total cost is 60, I'm just putting it there. I have no idea if it actually goes through it. ATC. That, but we definitely know it's going to be below the price. So to get the profit, we just need to take the difference between what? We just need to take, I'm going to erase this here. We just do ATC profit equals PM minus ATC times QM. Okay. And we know all of these things. So we can just get, okay, 77.5 minus 60 times 45. Did anybody calculate this out? Do it. What we get, Logan? 787.5. Thank you, Maddie. 787.5. Okay, I didn't ask you to graph that on here, but if we had to, we could, right? We could say, okay, profit is just going to be this rectangle here. Okay. Any questions? Yeah, Maddie.
For the profit, ATC wasn't put in the horizontal line, and it's like, you know, the code.
Yep.
Would you take the value of ATC that intersects PM?
Yes, 100%. I mean, I could even, we could change this and say ATC equals 60 at QM even. Okay. And that'll give us the same thing. Yeah. So let's say that it looked like this instead, which this is more realistic. I just didn't have time to, I didn't have time to come up with the good way of doing this. Okay. Same graph. We don't change anything. Is that what you were looking for? Okay, yeah. So good question, because that's definitely something that could happen. It's tough in this class to get ATC and marginal cost curves that are exactly right. So a lot of times I'm just going to say constant, but it's not really, there's more to it, and you'll learn more about it if you go take 410. Yeah. Okay, Eric?
Would you have to give us ATC for that problem?
100%. If you don't have the ATC, if you don't have the average total cost or total cost in some way, like what I could do is I could tell you the total cost at the quantity, which then again will tell you the average total cost, right? But yeah, you need something about total cost in there, or you cannot get profits, because profit is total revenue minus total cost. Okay, I might not give it to you this exact way because I might want you to know how the relationship works between total revenue, total cost, average total cost, price, etc. But yes, yeah. Question in the back? No, you did. Okay. All right, we can do that for sure. So is min ATC at 60? Oh, this is a good question from Clayton. Okay, so he asks, is the minimum of the ATC at 60? No, it does not need to be that way. The minimum of the ATC crosses through the marginal cost. Okay, that can be below 60 for sure. All right. Yeah, you always, whenever you draw ATC, make sure the minimum goes roughly through marginal cost, or it's just going to be half point off, because I want to know that you know that. Okay. Yeah. Divide by the quantity. Yep, exactly. Yeah.
Like linear across at the value of 1%. If we were to do that on the exam, like we have to draw it, or are we allowed to draw it?
So my recollection is you're given an average total cost curve, right? In recitation. like you're given an equation for it. Yeah, so, and I can talk to them about this. So it's totally cool to do what I'm doing here and draw this through here, because that's the average total cost of the quantity, and then you're gonna want to figure out the profit. But if I ask you to draw the curve, then I would like to see the curve. I didn't ask you to draw the curve here, so no problem either way. Is that helpful?
So when we solve it, that's given us at the quantity, but if we're drawing, we want us to draw.
If I give you an equation and I say graph the equation, I want you to graph the equation, but then to figure out how to plot profits and whatever, yeah, absolutely, do whatever you want. Okay? Is that helpful? Okay. Yeah, Maddie.
In the recitation, you're giving the total cost and the quantity, and we divided that to solve it.
Okay, then in that case, I would not care too much if I don't ask you to graph the ATC. Yeah, so so that's a good example there. And yeah, so we're all good. Everybody who's had recitation. For those of you who hadn't, you'll see it on tomorrow. If I don't ask you to graph the ATC along with other things, and a lot of times I'm not going to because it's tough to think about, okay? Then you don't have to graph it. And so, yeah, Ishan's just drawing the thing across so we can figure out what the profits are, right? Just like what we do here, right? I say, okay, the ATC is 60 at this point, and so that's going to be part of our rectangle, okay? Good questions. Any more questions about this? So this is just like kind of the standard problem, okay? If you're somebody who is like me and you like to think about things in steps, it's like, okay, first I need to remember marginal revenue equals marginal cost. That's where the profit maximizing quantity is, okay? So I need marginal revenue, I need marginal cost. Set those two things equal, solve for the quantity, okay? Step one. Step two, the profit maximizing monopoly is going to charge the price at QM up to the demand curve, okay? Because that's the highest price they can choose at that quantity, okay? So draw that in, do that. Step two. Step three, to find the profits, total revenue minus total cost, or we can just remember this, what we would call a derivation of that, which is the same thing. And I went over that in class, how they're the same. But for the sake of monopoly, you can just, well, for the sake of any of them, you can think of P minus ATC times quantity. And if you had to graph that, I didn't ask you to graph it here, but I did ask you to solve for it, right? But make sure you know how to solve for or graph it. Next thing that we didn't go over that you might need to know about is what's the efficiency loss, okay? If I ever say anything about what's the efficiency loss, assume that we're talking about at equilibrium or just ask me about it. But usually in monopoly, actually pretty much always, you're thinking of comparing the monopolist quantity to the equilibrium quantity. Okay, so whenever you hear economists talk about efficiency and monopolies and how there's loss, welfare loss, they're always talking about those 2 points, okay? So make sure you can remember how to do that. That would be a good review for unit 1, because in unit 1, right, we need to know how to solve for deadweight loss in the presence of taxes, subsidies, externalities, stuff like that, right? Okay, so I hope that was helpful, and I hope it'll be helpful for you guys. Yeah, so efficiency, we're just talking about the total surplus that's lost. So if we were at the equilibrium quantity Q star, we would get all of this extra surplus, but we lose that surplus. So if I say anything about efficiency loss or welfare loss, that's what we're talking about. And I'm probably going to try to be a little bit more clear and use the language we use in class, but you guys who go on and take more econ classes are going to hear efficiency loss, welfare loss, and they're just going to assume that you know that what we're talking about is total loss of total surplus, basically. Yeah. In this class, oh gosh, let me see what the book says about it. Remind me if I don't remember it to talk about it on Monday. I will try to be precise and say deadweight loss only. But what I'm telling you is if you go take 410, they're going to talk about loss of efficiency or loss of welfare. And they're talking about deadweight loss in context of monopoly. They're talking about this. this triangle right here. Okay. And so I'm just trying to say, because this class is supposed to prepare you for the next class, keep this in the back of your mind if you go take 410 next semester. Okay. Yeah. Is efficiency loss the same thing as deadweight loss? I would say in general, I think of it that way, right? Like when we think of the efficient quantity versus the equilibrium quantity in unit one, right? We have loss of loss, like deadweight loss, but it's like loss of the efficient quantity. Okay. Okay. Cool. Okay, so now we're gonna move to something new. I think it's important to pay attention to this. This is going to be something kind of different than things that we've done in the past for oligopoly, and the important concepts are going to be strictly the things. The market structure itself is important, and then we're going to talk about this new idea, game theory, that is going to be specific to what I'm going over in class. Okay. Your book might talk about it a little bit, but how we're going over it in class is what's going to be important, okay? So oligopoly is a market structure in which a small number of firms compete, okay? I know that I talked about some other things earlier in class, like barriers to entry and things like that, but today we're gonna focus on that idea about competing, okay? Because that's one of the most interesting and important topics in all of economics. There are a few firms, and then those firms can choose whether or not they want to compete with one another or collude with one another. Okay, this is something that goes on actively every single day. If they compete with one another, that's really good for the consumer. If they collude with one another, that's good for the producers. Okay, so you can imagine the people who are trying to be oligopoly, or the firms that exist in oligopoly markets, are constantly trying to figure out how they can collude with one another so they can act more like a monopoly. Yeah. Go ahead.
Is that how like you have like different gas stations that mix prices together?
That is one really good example. Some of you might have seen this before in your life, but most gas stations that exist on the same corner will have like a unspoken understanding, maybe a spoken understanding, that they will change their prices at the same time during the day. So if you've ever seen gas prices change, and you might be at like a stop sign and you see like the lights go off on both of them, they do it at the same time. A lot of places, not everywhere, but like that is a good example. Now, if there's some kind of spoken understanding that they do this, that is super illegal. But in the case of the gas stations, it's probably just that one saw the other doing it a certain time every day, and then they just started matching them. Okay. So that's a really good example. I don't know if that comes from a book or just you read about it or something, but yeah, that's a good example of something that happens in the real world. There are lots of other really cool examples that I could talk about, but the idea is if they can collude and work together in some way, then they are able to have higher profits. So if you work for one of these firms and you're an economist, you're trying to figure out how to do these things. Okay, this is something that economists actively do. So we're going to focus in our class about this part of it. Okay, which means we're not going to write down any graphs for oligopoly, but we are going to talk about how to figure out when they'll make certain decisions. Okay, the first thing that we're going to talk about, or the way that we're going to do that, is through talking about game theory. Okay, game theory is the study of how people or firms make decisions in situations where attaining their goals, think of maximizing profits, depends on their interactions with others or other firms. Okay, now game theory is not unique to economics, but it's been kind of co-opted, and most of the literature that exists in the world today on game theory, which is like a math concept, is in the field of economics. Okay, for something to be a game, so to be defined as a game, it needs to have players, actions, strategies, and outcomes. Okay, players just means there are people who are interacting with one another. Action just means they have a set of things that they can do. Strategies just means that they will determine what actions they will take based on the other people's actions. And then outcomes are winners and losers. Okay, so you can think of any game that you might play, a board game, a video game, sports. I was gonna say sports game, but like sports games, you don't use it, but sporting events. These are all different types of games because you have players. The players can do actions. The players can create strategies, which are their responses to other people based on the other players' actions. And then there are outcomes based on their strategies and their actions that are chosen. What is the outcome, the winner and the loser? Okay. We're going to spend a good amount of time on this because it's a new concept for us. So if you're like, oh my gosh, this is the worst, don't worry. This is an intro today. We'll do some more next week. And also, I think there are definitely, Ishan is going to be really helpful in this type of stuff because he thinks about it a lot. And I can talk to you about more resources too if you want to go over other stuff. Okay. Because I don't know how much your book is going to have on this. Okay. Okay. So the way that we're going to evaluate how people make decisions is through a payoff matrix. That's going to be in place of our model that we would normally use. Okay, right? We normally are going to draw graphs, solve for equilibrium, solve for some other point, right? But we're going to talk about the payoff matrix instead. And the main thing that we're concerned about is going to be the Nash equilibrium. Okay. Nash equilibrium is just the equilibrium defined by a game where we can use it, we can solve for it using a payoff matrix, which just shows the payoffs from every possible combination of strategies. And then the equilibrium is when each firm's strategy is their best response given the strategy chosen by the other firm. Okay, I'll talk a little bit more about what best response means, but it's not like a trick phrase. It's saying if somebody is going to do something, my best response is to my best response is the thing that's going to give me the highest payoff. Okay. 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 So to find a Nash equilibrium, there are a few steps that we take. And this is, if you just remember how to do these steps and you truly in the part of your hearts believe it, then you'll be able to do this for any payoff matrix in any game that we come across. Okay. So first you find a player's best response to each of the other player's actions. I'm going to go through this quickly, then we're going to do an example of it. A best response is the action that leads to the highest payoff. You do this for both players, and then the Nash equilibrium is an outcome reached when both players are best responding. Okay. Something to note here is there are not always, I'm going to put this in parentheses, pure Nash equilibriums. Okay. So there are going to be some games where we go through and we don't find a Nash equilibrium using this. That doesn't mean you did anything wrong. It just means that you should go take 410 or 490 and you'll learn more about why that is. Okay. Okay, so the first example that we're going to talk about is the prisoner's dilemma. So let's think about like a real life possibility. Two people, I was going to pick two people in class and I was like, no, I'm not going to do that because I don't want anybody to feel like I'm picking on them. Two people have committed a crime. The police have evidence to put them in jail, but not enough to charge them with the full crime. Police put them in separate rooms and give them the option to confess. If neither confesses, they each receive 5 years in jail. If one confesses, the confessor gets a lesser sentence of 2 years, while the accomplice gets 15 years. If they both confess, they each receive 10 years in jail. Okay. So you have to think about these options. And in this case, we're assuming that both players know all of the outcomes that are possible, all of the payoffs that are possible. We have to figure out what, if we're interested in finding a Nash equilibrium is what we think will end up happening, okay? So the first thing that we would need to do is draw the matrix. I'm gonna zoom out. I know it's gonna be tough to see a little bit here, but just so if people didn't write this down, we have two players, okay? So we have player 1, P1, and player 2, P2. What are their actions? They can either confess or shut up. Okay, what are their payoffs? If they confess, if they both confess, they both get 10 years. If they both shut up, they get 5 years. And if one confesses, they get 2 and 15. Okay, so I'm gonna write all that down. Okay, we want a way to organize this better than just writing all of it down. So we're gonna do a payoff matrix. A payoff matrix is simple. It's just a matrix or table where we use this information that we have. Okay, so we have player 1. They can either confess or shut up. Okay, or you could say not confess or stay quiet, whatever it is that you want. And then you have player 2, and they can choose to confess or shut up. Okay, let me create those. Matrix. Okay, so if they both confess, they both get 10 years. So I'm going to do this. This is player 1. Okay. This is player 2. Okay, you always put player 1, or the row player is what it's called. You always put their stuff, their outcomes first, or their payoff first, sorry. Then if the row player, player 1, confesses, they get 2 years, and the column player gets, or player 2 gets 15 years, and vice versa, 15, 2. And if they both don't say anything, they both get 5. Okay? So if I ask you, if I give you a scenario like this, and I say draw the payoff matrix, this is how we would go about doing it. Who are the players? What can they do? What are their payoffs? Okay? Okay. Okay. Then the next thing that you're going to be asked, and this is going to be the extent to which we're going to care about game theory in this class, is what is the Nash equilibrium of this game? Okay. Nash equilibrium, I'm going to erase these parts here because they're just copied from the other page. Okay. Whoops. What is, if any, the Nash equilibrium? Okay, if you ever see me say NE, that's the same thing. What is the NE? The Nash equilibrium? Okay. first thing that we have to do is we have to figure out what the best response of each player is. I would say that this is pretty much the only thing that, like the only, other than drawing the payoff matrix, this is the only skill that we need to acquire for this class to do well on this topic. And I would say it's probably one of the hardest topics to understand in all of economics outside of opportunity costs. So if you have questions, please ask me. To get at the Nash equilibrium, we first need to know what each player's best response is. So what I do is I go through the payoff matrix and I say, okay, let's just assume, for the sake of clarity, that player 2 is going to confess. So we're somewhere in this first column. Okay, I'm player 1 and I'm thinking about what I should do, what my best response would be if, and I'm going to assume for now that player 2 confesses. If player 2 confesses, what should I do? What should player 1 do? Shut up? Okay, so let's think about it, okay? If I shut up, then I'm going to get 15 years in prison if he confesses. Oh, that's fine. That's good. So I'm going to get 15 years if he confesses. But if I think he's going to confess, I should confess because I'm only going to get 10 years. So what I do is I go through and I underline this so that I can remember my best response. If player 1's best response, if player 2 confesses, is to confess. Okay. Okay. Now let's just say we're in this column. Player 1's trying to think, okay, well, what if I think he's going to shut up? What if I think he's not going to say anything? If I think he's not going to say anything or shut up, then what would my best response be? Confess again, right? Because I get 2 years in jail if I confess, and I would get 5 years if I didn't confess. Okay. Now let's go through and do the same thing for player 2. I'm going to give you guys a couple of minutes to try it on your own, or maybe a minute, and then we'll come back together and we'll talk about whether what you guys got for the player 2's best response. Okay. For both, for any option, what are player 2's best responses? Okay. So what do we think? If player 2 thinks player 1 is going to confess, what should player 2 do? Confess, right? Because 10 is less than 15. So we're good to go there. If player 2 thinks that player 1 is going to shut up, what should he do? Confess again, okay? Because 2 is less than 5. Okay? So hopefully it's not that difficult. I will say that the one thing that I think is going to trip people up is just when they go back through it, getting confused about who's where and who's doing what. And so that's why I think really understanding how the payoff matrix is drawn and what information it's communicating will help you become fluent in just going through this, okay? Because once you get that, then the best response is easy. Like if we were to write this out, is 10 greater than 15? No. So they're going to choose like that's all that we're doing every time. Okay. So the next question then is, what is the Nash equilibrium? Well, let's go back here, right? A Nash equilibrium is an outcome reached when both players are best responding. Okay. So the underlined numbers represent our best responses given certain actions, right? So in this case, our Nash equilibrium is going to be this cell right here. What does that mean? Okay, the outcome of confess is a Nash equilibrium. Okay, now there are a few things that I want to clarify here. Okay, the first one of which is I said the outcome. Okay, the outcome is two strategies when we have a two-player game. Okay, it's the two-player strategy that leads to an outcome. The payoff is the numbers. Okay, so if I ask for an outcome, you got to put the strategies down. If I ask for a payoff, put the numbers down. Okay, the payoff is 10, 10. Okay. Notice how we put 10, 10, and 10 years is like a lower number than 15. So just remember, you want to think about this as like the intuition behind, yeah.
Is it just the best outcome you think of confess like the best responding? Why is that confess?
Yeah, so good question. We're gonna go over, I think maybe there's yeah, good question. So the definition of Nash equilibrium is where best responses overlap. Okay. It's not necessarily what the best outcome might be. It's not necessarily what the most equitable outcome would be. It is just if there are two strategies, if there's an outcome where best responses overlap, where both players are best responding, boom, Nash equilibrium. That's all that we're saying, okay? Why is this important? Well, we're going to see that we won't see a ton, but over time, when players compete in a game, they figure out what this is and what happens here. We're going to talk more about this in class on Monday. But yeah, for now, we're just going over like kind of the structure and the basics of it, okay? Now, you might be thinking, well, this is stupid. These people are dumb, right? Because if they choose confess, they both get 10 years. But if they would have shut up, they both get 5 years, okay? But we have no way of, there's one thing that we're missing here. We have no way of cooperating, okay? These guys are in separate rooms from one another. They can't signal to each other that they're going to cooperate and have a better outcome, okay? So it might be the case that given other circumstances, you can get to what would be called a cooperating Nash equilibrium, but this is not. This is what is called a competing Nash equilibrium. Okay. Where both players end up doing the thing to kind of compete with one another and it hurts them in the long run, okay? Or hurts them in the outcome, okay? But it's kind of weird, right? Because we always think about Pareto improvements and efficiency or whatever, and you might think, oh, well, equilibrium is always efficient. It's clear, though, that this is not going to be the efficient point. It would be more efficient for them to just both stay silent and get the 5 years. Okay. Intuitively, like what you can think of is why that might not be happening is if I might tell you, oh, like when we go in to our things, I might say, oh, let's both like shut up or whatever. But then I'm just gonna like switch that on you and get 2 years and you're gonna get 15 years. So that's why you kind of think about it that they both end up confessing, okay? Okay. You might also think, well, this is also dumb because this is stupid. This is a stupid example. This has nothing to do with economics, right? Like there's no there's no firms, there's no people making decisions under uncertainty with like constraints, right? There's no like market that we're talking about here. Well, we introduced this topic in oligopoly because it becomes relevant pretty quickly right away, right? So let's think about an economic example. Suppose we have two gas stations that are both located at an exit 30 miles from any other gas station. So Logan kind of came up, like, got this example, although I didn't get this from the book. Each gas station can choose to set a high price or a low price. Okay. And we might want to think about, okay, well, what are they going to do? So I want you guys to spend about 3 minutes going through this with the people sitting next to you, or if you have questions, I can walk, like, just raise your hand, I can walk back and talk to you. Trying to find the Nash equilibrium, and then we'll come back together and go through it, okay? Okay, let's do like one more minute. All right. Okay. So we have two gas stations. We're trying to figure out what they will both do. If Exxon thinks that Shell is going to go high, Exxon would go low, right? Because they'd get 4 million, Shell would get negative 1 million. They're undercutting them. They're going to get more, like, they're going to get higher profits. Okay. If Exxon thinks that Shell is going to go low, Exxon will go again low, right? Because 0 is better than negative 1 million. And then vice versa, if Shell is going to go high, or if Shell thinks Exxon is going to go high, Shell will go low. If Shell thinks that Exxon is going to go low, Shell will also go low. Okay, so then what's the Nash equilibrium? Okay, the Nash equilibrium is the outcome. Okay, it's low, low, but the payoff from the outcome. Okay. Okay, so yeah, it's good to get that, like, go through that now. Low, low is the Nash equilibrium. Payoff is 0, 0. Okay. Just to be clear, the payoff is 0, 0. If I ask you for the Nash equilibrium, it's the Nash equilibrium outcome. Okay, and then I might say, what's the payoff from the Nash equilibrium or something like that. Okay, then I have one more yeah, one more thing I want to talk about before we go. So, the Nash equilibrium we said is low. Low. I want to talk quickly about what's called the dominant strategy. A dominant strategy is when the best response of the player is the same, regardless of the other player's strategies. Okay. So in this case, no matter what shell is going to do, Axon's going to go low. Okay. Right. No matter what Axon's going to do, shell is going to go low. Again, we're in a non-cooperating equilibrium here. This is an economic example of the prisoner's dilemma. If they could somehow cooperate with each other, then they might be able to be better off. Okay. The somehow cooperate part, we're not going to talk about much in this class, but if you go take other econ classes, this is seemingly all you will talk about in some of them. And this will exist with you forever. I like on a graduate exam as like a joke or something. I don't know why my professor put like a 30 by 30 payoff matrix. And he just said, find all the Nash equilibrium. And so stupid. It's so dumb. But anyways, yeah, so this is an example of non-cooperative equilibrium where each firm acts in their own best interest. If they were to cooperate, they could get at a better equilibrium where their payoffs would both increase. That's what I want you to remember about cooperation and competing. Okay, so that's all I have. Next week, we're going to go over another example. We're going to talk about this a lot more. We'll go over monopolistic competition on Monday as well. We'll also do a little bit of a review on macro. Yeah, that's all that I have. I will have office hours today from 12 to 1 like usual. Oh, wait, 12 to 1 or 1 to 2? 12 to 1. 12 to 1 like usual. And then if you have any outstanding questions, I know a couple of you, there were some grading issues from GradeScope. I fixed a few of them over the weekend. I know there are probably still a couple more. So just let me know. We can talk through that stuff. Remember, problem sets due not next Monday, but the Monday after that, if I remember correctly. Or no, Wednesday, next Wednesday, right?
It's the last day of classes.
Okay, last day of classes, which
December
is
1st, right?
December 1st, which is Wednesday. So next Wednesday. Okay. So remember the problem sets due next Wednesday. I highly suggest you do not wait till the last minute to do it. One, it's going to be graded for correction. Like in the same way that some of them, like other ones that have been, are. Two, it's going to be your best experience at getting feedback on how you're doing, in the sense that those questions are going to be similar to the questions on the test. So make sure you put a good effort in on that. Yeah, have a good weekend. For those of you who celebrate Thanksgiving, have fun, eat turkey. Yeah, I'll talk to you guys later. I'll stay up here for a few minutes if you have questions afterwards. Okay. And I'll put these notes up online, but they won't be, obviously there's